Welcome to EMScan Lab. Today what we'll be doing is showing you how you can effectively use the spectral spatial capabilities of EMExpert software to analyze a board that you're testing. So what we're testing today is a wireless access point. There's a few videos on EMScan channel showing testing of this. This is basically the inside of a wireless router that came off the shelf. We'll put the board on the ERX Plus and we'll do some testing to see what happens. We're using the ERX Plus as our test tool today. With the integrated spectrum analyzer and motion control, all we need is Ethernet connection to the computer, and there we'll be running the EMExpert software to do all of the display and analysis. So the test has already in fact been run. What we're doing now is showing you the post-analysis capability of the software so that you can actually do all of this kind of testing offline. You can even save these files, send them to colleagues who can open up the same data and do the same analysis that we'll be showing here. So the testing that we've done is already shown on the screen. We have measured the entire board over a large spectral range. So we've measured it from 30 megahertz up to 500 megahertz, and you can see some of the key hotspots on the board, as well as a large number of spectral emissions. So we've overlaid these results directly on top of a photograph of this board, but you can also import Gerber files into the software to do more exact comparisons. Here what we'll be finding of interest is over to the left side of the board. And now this is up to the designers or the people doing the testing to figure out what the critical elements are that they want to analyze. For us, we'll be looking at this section of the board at a lower frequency range. So in fact, we'll quickly move to our high resolution scan that we've done. And you can see we've cut down on the spatial range to just a small portion of the board. And we've also cut down on the spectral range to just cover 130 up to 190 megahertz. But we've run this test at level 5, which is 0.5 millimeter spatial resolution. So now with this test already, you can start to see some really fine detail. So you see a lot of spectral emissions, and you can also associate those with particular features on the board. What I can do is change the transparency setting of that overlay to highlight the detected emissions. What I'm going to do now is start to analyze these different locations and different frequencies. So first of all, I'm going to pick out this trace along the edge. Might be curious to see what the spectral emissions are from this location on the board. So I just make a small mark there. You can see an X on the board. Coming over to the spectral view, if I use user composite, it's going to highlight just the frequencies coming from that location on the board. So we can see that the emissions from that trace are very different from the large area that we tested. There's just a few spectral signals that are located along this trace. And we can verify that that's consistent along the trace by selecting some different areas. And we very quickly determine that that's the case. So now that I've detected maybe the 3 key harmonics coming from this trace, what I can do is see if those are related to other areas of the board. By coming into the spectral emission side and clicking on that peak, now I can isolate just that frequency in the spatial view. So again, I come over to the spatial view and I choose user composite view. And now I'm highlighting just that one peak. And you can see a large portion of the board doesn't radiate at all with these frequencies, but there is some very interesting content. So we can clearly follow that frequency along to that trace, getting to this area of the board, and then coupling through these other features. And again, once we have a picture of the board like we're showing here, or if we'd imported those Gerber layers, you could very quickly correlate those with traces or components in your design. Now if we want to look at the other harmonics just to see if they're consistent, we just reset zoom and come over to pick another one. And in fact, even though that's a lower signal level, it looks to be very similar in distribution. So now from this test, it seems clear that most of those are related to that one trace. The third component also has a little bit of overlap. Now this could be because it is a harmonic that just happens to be multiple, and we can determine that by coming in and selecting this new area that has shown up with this third harmonic. So again, I just select an X over here, pick that area of the board, and then view the emissions, and they look very similar. Now if we go back to the main composite view, you can see there's a whole bunch of hotspots that weren't part of those key emissions. So to analyze those, same process, I just click on that area of the board and I can very quickly pick up the spectral emissions from that particular location. If I want to compare the spectral emissions from that one location compared to the entire board, I come to the full and user composite, which is going to overlay the entire board emissions versus what I've just detected at this one. And this is effective at telling me which frequencies are not at that location. So here I can come in, zoom in on this location. These are one of those key frequencies that we haven't seen yet. So all we need to do is come in here and select this one, and then go back and look at the user composite view. And this is very quickly pulled out a hotspot related to a specific frequency and its harmonics that were not part of that first set that we looked at. So by combining this spectral and spatial analysis and going back and forth between these two views, you can very quickly understand different parts of your design. So you can pull out different clock signals, how those harmonics propagate around your board, as well as introducing stuff like switching noise, maybe RF harmonics might be present, but anything that's related to the emissions of your board, you can pull it apart in terms of this spectral and spatial capability. So again, that shows how to use that special capability, the EMXpert software, to do this spectral and spatial analysis. If you have any questions or comments, you can post those below, and join us again at EMScan Lab for more videos.